Greetings and welcome, friends. We were talking about like segment and measurement and construction and stuff like that. Segment addition postulate. Oh, like bisecting a segment, midpoint and distance. Things like this. So it says identify the segment bisector of JK. Just kidding, guys. The segment bisector in this case is a point. So M is a segment bisector. And then it says find JM. So if this is a segment bisector, then these two segments, JM and MK, are congruent to each other, indicated by the tick mark, like so. And if they are congruent, then their measures are equal. Their lengths are equal by the definition of congruence. So 7x plus 5 is going to equal 8x. I could then solve it, subtract 7x from both sides, and I'm going to get 5 is equal to x, or x equals 5, using the symmetric property of equality, where I can switch the two sides of an equal sign, flip it around, just in case you like to read it from left to right, which I do. I like my variables on the left. Now, they didn't ask us for x, they asked us for jm, and jm is going to equal 7 times x plus 5, and instead of x, we're going to go, what? Substitution property of equality. We're going to plug that 5 right in there. Well, there's multiple ways you could have written it. All right. Yeah, so, and then you didn't finish the problem, is that what or? Oh, yeah, that's the classic. That's what I do all the time, yeah. Also, I want to point out, because these two things are equal, you also could have just plugged 5 in there, and 8 times 5 also would have been 40. And then using transitive property, you could have said Jm is equal to Mk, which is equal to 40, and therefore Jm equals 40. Yeah, where are we at? Scroll bar. All right, the endpoints of CD are given. Find the coordinates of the MP. The midpoint M is going to equal the average of the X's, add them up, divide by 2, and the average of the Y's, Y1 plus Y2 divided by 2. And I'll label these, because I think I messed up the other day, didn't I? I might have. All right, X2, Y dose. Man, that Y is pretty awesome. It's like an upside down, or no, a rotated H, 80-degree rotation. Or a 4, it looks like a 4. So the midpoint is going to be 4 plus -2 divided by 2, or -2 plus 4, doesn't matter which order, and a 9 plus 0 divided by 2. So my midpoint is going to equal 2 over 2, and 9/2. And for midpoints for coordinates, I can tolerate decimals sometimes. I'm usually not a fan of decimals. I usually like the improper fractions if I'm going to algebraically plug it back into things later. But yeah, average of the x's, average of the y's. I like that as a formula. It just feels like it makes sense. The formula is what it is. A little bit trickier is when you have to use the formula kind of backwards. So if I have the midpoint of the x, that would have equaled the average of the x coordinates, right? And the midpoint y coordinate will equal the average of the y coordinates. And in this case, I know one midpoint, or I know the midpoint, and one end point. So the end point, I could call this x2 and y2. The midpoint, I could call xm and ym. Something like that. I'll plug in what I know and solve for what I don't. The classic algebra right there. I've said this many times, that if Mr. Waddy was some sort of like toy that you could buy like Woody from Toy Story, and I had a pull string back sort of speaker audio play feature, you'd pull the string, and one of the things I would say is, plug in what you know and solve for what you don't. And like, that's one of the 3 things I would say, besides like, there's a snake in my boot, which, of course, I would have to say that even though it's not math related. It's just something I would say. X1 plus -2, I'll call that -2, why not? And let's see, then I'll plug in, no, I made an error, guys. Look at that, that's the best 8 ever. 0 is equal to y1 plus nueve over 2. Now, in order to solve these, I'm going to multiply both sides by the debottominator first. Oh yeah, the debottominator. 16 is equal to x1 minus 2, and then I'll add 2 to both sides. I think that's the easier way to do it rather than creating unnecessary fractions. So symmetric property of equality, x1 is equal to 18. And over here, we'll double both sides. Let's see. Let's cruise through this. You guys are expert algebraticians, right? When it comes to, like, elemental powers and you guys being the avatars, you guys, like, you already knew algebra when you came here. You're here to learn earthbending or something. Which, actually, geometry... Oh, thanks. You caught me. You caught me. In terms of geometry, geo as a prefix means earth, and metry is to measure. Geometry literally means the measures of earth. So when it comes to math, I'd like to think of geometry as the earth bending. Yeah, it's pretty good. I've been actually I rewatched Aang, the Last Airbender, Avatar, whatever, with my son Everett recently over the summer. It was pretty good. Yeah, it's yes, or was it Amazon? I don't know. It was one of them. So the other endpoint, did we have a name for this endpoint? Well, let's see. GH. So it's either G. Oh, there was H. So we're point G. So point G would have been 18 comma negative 9. That one's tricky, right? That one's a little bit more work for you. Let's see. Do I have like one more cool problem to do or something? Classic distance. So we talked about distance formula before as where you could do the absolute value of the difference of the coordinates when they were horizontally or vertically oriented to one another. Distance formula for points that are diagonally oriented, you do this one, which is completely just the Pythagorean theorem rewritten, is all it is. So let's see, I'll just plug it in. Plug in chug, as they say. That's another thing my pull string would tell you. So the distance is equal to, actually, I could even call that distance EF, couldn't I? Because EF represents a number. Segment EF, right? That would be the picture or the diagram or the drawing. Square root of 3 plus 9 all squared. Plus. I was worried. Yeah. Man, I was doubting myself, guys. I doubted myself. But you guys would catch my errors. 12 squared. Ooh. Uh-oh. So this is going to be 144 plus 144. Yeah, in terms of the order of operations here for the distance formula, it's a bit of work here. So that's 288. You could get a decimal approximation of that, square root of 288. But I don't know. Actually, that's about, notice my squiggly equal sign here. It's like not too confident of itself. Yeah. I made it. I'm supposed, man. Yeah, you're right. You're right, friend. Man, this video's the best. Minus. Here we go. All right. I was all excited about that. 3 minus 9. Actually, speaking of correcting me, I did see one of those, like, Kermit talking to the evil Kermit self memes the other day, where it was all like, hey, the teacher just made a mistake in his math problem. I should let him know. And then it was like, evil me to me was like, no, let's tell him after 15 minutes. So he has to, like, correct it all after. So that's... but I'm assuming that wasn't your evil you overcoming. Okay, I appreciate it. Negative 6 all squared is 36. 2 squared is 4. I'll just make this a giant 4 there. That's pretty good. So that's going to be the square root of 40, which is probably what, like 6 point something? All right, 6.32. I did? Oh, what? Oh my goodness. Color me embarrassed. So wait, where's my mess up now? Negative 6 all squared is 36, right? Why do I have a 9? Oh, man. Wow. Are you willing for me to just put your work under the document camera? Here we go. We'll just... All right. Go to check out Liam Math on YouTube, friends. He's going to be the one that'll help you out for the rest of the semester. Ugh, man. All right. What number are we even on? 25. Here we go. All right. Look at this, friends. Here's Liam Math. Yeah, 6 minus 3. I had a 9 in there for some reason. I don't even know. What was I? All right, so 3 squared is 9. And then, yeah, square root of 13 is irreducible, but we could get a decimal approximation. But I'm a fan of the square root of 13. All right, thanks for watching. Remember, that's Liam Math. If you go check out his YouTube channel, he'll be way better than me. Bye-bye.